So, chapter 2 is sets, and I forgot what we went over. Oh yeah, we went over a lot of things. Okay, so we defined a set, and then we talked about the empty set with no elements in it. That little symbol E is an element of, what else do we do? Z is integers, N is natural numbers. We talked about the cardinality of a number, how to count how many numbers were in a set. We talked about equivalent sets, which means they have the same cardinality. And then we talked about finite sets versus and equal sets. So we've had a lot of things in this first part, right? Okay, so now let's go to the second part, and this is not going to be nearly as much. Okay, so let's let S be a set of dual credit students. Okay, so we have ML, HC, H squared, M squared or MM. Who else is in our group? We have AE, that's a person, and 1, 2, 3, 4, 5. There's 3 more. JS is a person. I can't remember. Oh, EK. And who am I forgetting? Who am I forgetting? Do you know everybody in our dual credit class? Dang it. Oh, Nicole. Alright, so there they are. Okay, now a subset would be, let's take these 2 people right here. These are the 2 that actually come to second period class. So they're a subset of set S. Okay, so the definition is set A, so we're going to call A would be HC and H squared. Many of you on the test did not do roster method correctly. You had to have the squigglies as well. You have to list them all out. So that's a little thing I noticed in the test. We lost a point there. Okay, so if set A would be a subset of S if every element in set A is also in set B, or in my set S. Okay, and then this little symbol, you see the symbol? Okay, the other little symbol with a line through it would mean that set A is not a subset of B. And the definitions here are really, really important, okay? So in set B, so this is not a subset, there has to be at least one element in A that's not in B. So here we have A and B. Oops. Okay. We have both A and 5 for us. And then ask us, is A a subset or is A not a subset of B? Well, 1 is in A. I mean, 1 is in B. 3 is in B. 5 is in B. 6, however, is not in B. So there is at least one element in A that is not in B. So that makes it not a subset. You think, well, this is simple. And it is simple. So far. Okay? So let's look at the next example. So set A is that it's X such that X is a letter in the word roof. So in roster form, that'd be R-O-F. And B is the letters of the word proof. So P-R-O-F. And I have every one of these letters is in this one. So it is a subset. That's it. Piece of cake. So far, easy, right? Easy squeezy. X is a day of the week. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Is there anything in this set that's not in this set? No. So it's a subset. Even though they're the same set, this is kind of important, okay? These are the same set, but A is a subset of B, which bugs me, okay? It bugs me because I always think subset means there has to be at least one thing that's not in there, right? I want it to be a smaller set, but a subset actually can be the exact same size. Okay. Now, just to confuse you, because other people didn't like the idea that a set could be a subset could be the actual set itself. Okay? Oh wait. I need to throw another one on this one. Sorry. All right. Let's use this notation right here. Okay. Do this one. Is the empty set a subset of B? What do you think? Yeah, we think no, right? But let's look back at the definition. It means that every element in A is also in B. Well, since there are no elements in A, every element that is in there is actually in here. And the other way to undo this is that the not a subset, is there at least one element in A that's not in B? Well, there's nothing in here that's not in here. Everything in here is also in here. So this is actually a subset. This is the weird one. So there's two weird subsets. The empty set, and basically you could say this, the empty set is a subset of every set. So I'm going to put that at the bottom. I think it's somewhere else in our notes. Therefore, the empty set is a subset of every set. Okay. But people didn't like that, and I don't like it. Okay? So they made up another little term. Set A is a proper subset and it's expressed with just that sideways U. Okay? It's a proper subset if it is a subset of B, but it's not actually equal to B. Oh, here's that little statement. Okay. The empty set is a subset of every set, and it's a proper subset of all sets. However, it's not a proper subset of the of itself, or the empty set. Okay, so basically this right here. Is the empty set basically this? I'm gonna put this right here. I hope you can see it at home. That's red. Okay, so I'm asking. I'm gonna redo this. Forget that. That's not written right. Okay, remember the empty set is a subset of every set. However, it's not a proper subset of itself. It's weird. It's really comes down to definitions. Okay. Ready? Let's see if we can either put in proper subset, or probably we're going to put both in, both of them. Okay? So 2, 4, 6, 8, is that a subset of 2, 8, 4, 6, 10? And it is. It's a subset, yes, and it's a proper subset. So this would be both. The only time it's not, the only time it's, you know what, we should just define improper. Improper subset is equal to the set itself. Every other subset is proper. Most of them are going to be proper. Most of the answers on these types of things are going to be both. Okay, so X is a person who lives in Atlanta. X is a person who lives in Georgia. Well, people who live in Atlanta do live in Georgia, and that's a much smaller group than that group. So, oops, sorry, subset. Actually, both again. You can actually do both. And this last one is the one that you can't do both. Because these are the same set. Therefore, it's the improper subset. I think I screw this up every single time. It's not that one. It's that one. So this is both. This is both. And this one is just a subset. I don't love this. I don't like how this is done. Maybe we'll work on this some more. I'm going to look for some stuff. All right, look at the next page. Maybe this will help. All right. Let's look. Ready? Let's just look at this very first one. This very first set AB. Okay, so we're looking just at A, comma B. Now tell me what are some subsets of that. Subsets of AB. What did I hear? Did I hear A? Yeah, I did hear that. And I heard B. And I heard A, comma B. And then there's one more subset, which is what? The empty set. Okay. So there's 4 of them. So the set AB has 4 subsets. Now, let's look at the set ABC. Okay, so let's write down its subsets. A, B, C, I got AB. AC. BC. I got A, B, C, and I got the empty set. Can you find any more? I think we found them all. I think we did. Okay? So this one had 4 subsets. This one had 1, 2, 3, 4, 5, 6, 8 subsets. How many subsets do you think A, B, C, D will have? Is this a pattern? What do we think? 4, 8, 12? All right. Let's try A, B, C, D. Are you doing it already? No? How many subsets can you find of the set A, B, C, D? Find A, I can find B, I can find C, I can find D, I can find AB, AC, AD, BC, BD, CD. Have I got my 12 yet? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Got 10 of them. Oh, the full set and the empty set. Would that give me the 12? That gives me the 12. Is that all the sets there are? Or are there more? Oh, what about this set? A, B, C. How about A, B, D? How about A, C, D? And how about B, C, D? Now how many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now I got 16. That also seems like it could fit a pattern. We start with 4, 8, 16. Seems like we're doubling every time. Do you want to spend time and do A, B, C, D, E? It would take a lot because there's actually 32 subsets. Okay. So the number of let's see if I can find the notes. Okay, the number of distinct, that's a good mathematical word, means there's nothing else like it, of a set with n elements is 2 to the n power. So it's a little formula. It's not on your sheet. You're going to have to know this one. Okay? The number of distinct proper subsets is 2 to the n minus 1. Basically, we're saying there's one improper, and the improper one is the set itself. So it's a little tiny bit of formula. It's not too difficult. It is somewhat hard to distinguish between proper subset and subsets. So I'm going to do one more thing and we'll be done for today. All right. I'm going to highlight those three right there are the improper subsets. And I think it's easier to realize how many proper subsets there are if you realize that there can only be one improper one. Okay, so work through your homework. If you have questions, let me know. And we are well on our way through Unit 2. I'll have this loaded up soon. Is that enough for today?